Hi everyone. Today we're going to go over chapter 3.4, derivatives as rates of change. Okay, let's get started. Today the objectives for this lesson is going to be, we're going to go over the formula for average rate of change. We're going to go and we're going to find an example on how to find like a certain value given a function and a derivative of a function, some study advice, and some practice. Okay. So the average rate of change formula. The average rate of change of the function of f over that same interval is the ratio of the amount of change over that interval to the corresponding change in the x values. It is given by f of a plus h minus f of a over h. As we already know, the instantaneous rate of change of f of x is at a, and it is its derivative f of a, f prime of a. Here are some applications. So we use derivatives in physics and economics. In the left picture, it's showing the relationship between position, velocity, and acceleration, which I will go over in a few slides. And then we can also use it in economics. We can use it to find the marginal cost, revenue, how much the average cost of something is. Basically, it's like good for businesses to figure out like how much money they're making with their products and stuff like that. Perfect. Okay, let's go over this first problem. If f of 3 is equal to 2 and f prime of 3 is equal to 5, estimate 3.2. Okay, let's go ahead and write that down. Wrong screen. Okay, so we know that f of 3 is equal to 2, f prime of 3 is equal to 5, and we want this. Okay, so there's a formula for this. That formula is going to be f of a plus h is equal to f of a plus h times f prime a. Okay. So we know that h is going to be 0.2 because we're going to set a equal to 3. If a is equal to 3 and h is equal to 0.2, that gives us 3.2 when you add it together, right? So let's go ahead and write that out. F of 3 plus 0.2 is equal to f of 3 plus 0.2 f prime of 3. Okay, cool. Now we're going to rewrite this so that it's f of 3.2 is equal to f of 3. But we know f of 3. F of 3 is 2 plus 0.2 times f prime of 3. And we know that f prime of 3 is 5 because it was from our given information. Okay, so if I was going to simplify this more, it becomes 2 plus 1, which is ultimately 3. Therefore, the value at 3.2 is going to be 3. Awesome. Now, this is the application of derivatives in physics. Let s of t be a function given the position of an object at time t. So this is related to the image that I showed you guys earlier. So velocity and acceleration have a relationship with position. And that relationship is that the velocity is the derivative of position, and acceleration is the derivative of velocity. Or, in other words, the acceleration is the double derivative of the position. One thing to note is the speed of an object at a certain time is given by the absolute value of the velocity. It will never be negative. Okay. So let's go over a practice problem that uses position and velocity. The position of a particle moving along a coordinate axis is given by s of t is equal to t cubed minus 9t squared plus 24t plus 4, where t is greater than or equal to 0. And we want to find v of t, time is the particle at rest. And I think I'm gonna stop short today. Okay, I went ahead and wrote it. So we're given this formula here, and we want to find the velocity. Now remember, the velocity is the derivative of position. So we're gonna go ahead and find the derivative in parts. 3t squared minus 18t plus 24 plus 0, because for the derivative of a constant is 0. And that is all we need to know for part A. Part B is asking, when is the particle at rest? So when a question like that is asked, it's saying when v is equal to 0. When? So if we want to know when it's equal to 0, we just set v of t equal to 0. So v of t is equal to 0. So we're just going to go ahead and do 0 is equal to 3 of t squared minus 18t plus 24. Okay, we can go ahead and simplify this further by factoring things out. 3t squared minus 6t plus 8, which is equal to 3 times t minus 4, t minus 2. Okay. So we want to know the time. So we can do this in parts. If 0 is equal to t minus 4, t is going to be equal to 4. The way I got that was I added 4 to both sides. Let's do that again on the other side. If I add 2 on both sides, t is going to equal 2. So at t equals 2 and t equals 4, the particle is at rest. Okay, and I think that's all I have for today. Remember, guys, some study tips are practice. I'm gonna say it in like almost every video. Practice, practice, practice. When you are in college or whatever, like ask for help, ask your teachers, ask your peers, like anything helps, really. Okay, guys, thank you so much for listening, and I'll see you guys in the next video.